So here is another question on specific heat, latent heat and calorimetry. It is given, calculate the heat required to convert 3 kg of ice at minus 12 degrees Celsius kept in a calorimeter to steam at 100 degrees Celsius. And then some information is given about specific heat of ice, which is equal to 2100 joule per kg per Kelvin. Then specific heat of water, which is 4186 joule per kg per Kelvin. Latent heat of fusion, which is equal to 3.35 into 10 to the power 5 joule per kg, and latent heat of vaporization, which is equal to 2.256 into 10 to the power 6 joule per kg. So here if you see, these values are in terms of Kelvin, but the information in the question, it is given in terms of degrees Celsius. So we'll see how we'll utilize this information. Now let's understand the sequence of this transition, how this transition from ice, 3 kg ice at minus 12 degrees Celsius to steam at 100 degrees Celsius will take place. So first we have is the, let's say we have ice. So we have 3 kg of ice at minus 12 degree Celsius. First we, the conversion will happen is ice at minus 12 degrees Celsius will get converted into ice at 0 degrees Celsius. Okay, ice at 0 degree Celsius. So a temperature change of 12 degree Celsius. Now we have already discussed in a lot of questions that change in temperature, increase or decrease in Celsius, will produce the same change in Kelvin. So a change of 12 degrees Celsius is same as a change of 12 Kelvin. But here that does not mean that specific temperature of 12 degrees Celsius is equal to 12 Kelvin. No, change in temperature. Okay, numerically they are the same. I have demonstrated it in different ways, so I will not go into that. So here change of 12 degrees Celsius, that is from minus 12 to 0, is the same as a change of 12 Kelvin. So here what will come into play? Specific heat of ice. Okay, C, ice. So here the heat required, this is the first step. So the heat required for transition from 3 kg of ice at minus 12 degrees Celsius to 3 kg of ice at 0 degrees Celsius, same mass, here also it's 3 kg, here also it's 3 kg, is equal to ice, C ice, delta T. Okay, so here let's use the subscript delta T1 for the first step, okay, delta T1. So here it is equal to, mass of ice is 3, specific heat of ice is 2100 joule per kg per Kelvin, but here change in Celsius is same as change in Kelvin. So here we'll use 12 Kelvin because a change of 12 degrees Celsius is same as a change of 12 Kelvin. So this is coming around 75600 joules. So this is the heat required for the first transition. Okay, the first step. Then the second step, the second step or the phase of the transition, which is this ice at 0 degree Celsius will get converted into water, that is solid to liquid, water at 0 degree Celsius. Okay, so this transition will happen through latent heat of fusion. So temperature is remaining constant, so this heat which will be supplied, it will remain hidden and it will be used up in converting the ice in solid phase into water, which is in liquid phase. So I have discussed this in detail in the concepts related to latent heat, the various transition diagram of ice to water I have explained in detail. So you can watch all the theoretical videos first and then watch the numerical part. Okay, so same mass of ice 3 kg, and here also the mass of water, it will remain 3 kg. So here the heat which will be, this is the second step, so the heat required to convert 3 kg of ice at 0 degree Celsius to 3 kg of water at 0 degree Celsius constant temperature involving latent heat of fusion is equal to the mass of ice into latent heat of fusion. So which is equal to, it is coming 3 kg of ice into latent heat of fusion, information is given 3.35 into 10 to the power 5 joule per kg. So it is equal to 1,005,000 joule. So this much heat will be required to convert ice at 0 degree Celsius to water at 0 degree Celsius at constant temperature using latent heat of fusion. Okay, this. Next is the third step. The water at 0 degree Celsius, it has to be converted into water at 100 degrees Celsius. Okay, water at 0 degrees Celsius has to be converted into water at 100 degree Celsius. So a temperature increase of 100 degrees Celsius, which is the same as 100 Kelvin. Okay, so here specific heat of water, it will come into play using MC delta T, this relationship. So wherever there is increase in temperature, specific heat concept will come into play. Wherever temperature is remaining constant, there latent heat concept will come into play, whether it is latent heat of fusion or latent heat of vaporization. So here specific heat concept will come into play. So here this water here is 3 kg, here also it is 3 kg, okay, mass of water. So here the heat required to convert water at 0 degree Celsius to water at 100 degree Celsius, 3 kg of water, that is equal to mass of water, specific heat of water and delta T. This is the third step, that's why I'm using the subscript 3. The temperature increase during the third step. So mass of water is 3, specific heat of water is 4186 joule per kg per Kelvin, and temperature increase of 100 Kelvin. Okay, because increase or decrease of temperature in Celsius is the same, numerically it is the same increase or decrease in Kelvin. So into 100. So it is coming 1,255,800 joules. So this is the heat required to convert water at 0 degrees Celsius to water at 100 degrees Celsius. Next, the fourth step. Let me use a different ink. So in the fourth step, the water which is at 100 degrees Celsius, approaching the boiling point. In that case, it is the ice point, 0 degrees Celsius. So always in these kind of questions involving water, ice, water, always remember two important temperatures: 0 degrees Celsius, 100 degrees Celsius, ice point and steam point. So these two temperatures are very critical. We always use this as the reference points, lower fixed point, upper fixed point. So always these two temperatures are very important. So water at 100 degrees Celsius is to be converted into steam at 100 degrees Celsius. That is asked in the question. Transition from minus 12 degrees Celsius ice to steam at 100 degrees Celsius. So here temperature is remaining constant. So wherever temperature is remaining constant, it means latent heat concept will come into play. So latent heat of vaporization. So that will come into play. Same, it's here the mass. Okay, the mass of water here is 3 kg, and here for the steam it will be also 3 kg. So here it is the heat required in the fourth step to convert water at 100 degrees Celsius to steam at 100 degrees Celsius is mass of water into latent heat of vaporization, which is 3 kgs into the latent heat of vaporization is given 2.256 into 10 to the power 6 joule per kg. Okay, so it is coming 6768000 joule. Okay, this is the amount of heat required to convert water at 100 degrees Celsius to steam at 100 degrees Celsius. So we have got four different types of heat energies required. So the total heat required, okay, you can use the black pen, okay. So the total heat required for transition of ice at minus 12 degrees Celsius to steam at 100 degrees Celsius is equal to Q1 plus Q2 plus Q3 plus Q4. So first step, which is the conversion of ice at minus 12 degrees Celsius to ice at 0 degrees Celsius at specific heat of ice. So it is coming around 75600 joule. Then in the second step, conversion of ice at 0 degrees Celsius to water at 0 degrees Celsius, constant temperature, so latent heat of fusion. So it is coming around 1005000 joule. Okay. Then in the third step, conversion of water at 0 degrees Celsius to water at 100 degrees Celsius, specific heat. So it is coming 1255800 joules. And then the fourth step, where we converted water at 100 degrees Celsius to steam at 100 degrees Celsius. So this fourth step heat energy required, that is equal to 676800 joule. Okay, so the total result, the total heat energy required, it is 9.1044 into 10 to the power 6 joules. This is the total heat energy required. Okay, so this is the final result, the final answer. So I request you again to please watch all the videos, the theoretical videos related to all the concepts which we have discussed, the numericals which we are discussing, starting from heat, temperature, temperature scales, specific heat, latent heat, water equivalent, calorimetry, transition of state, everything I have discussed. So please watch all the videos again, so that you can understand these numericals in a better way, for a quick recap. Okay, so this is the result.